things. All right, so we're going to be covering 4.6, hopefully 4.7, maybe 4.8 today. So 4.6 for this first video is going to be on directional derivatives and the gradient. So again, if you're someone who takes down notes, go ahead and start writing down those definitions. Obviously, if you take shorthand notes, you want to at least do the things that I starred. And then we'll move on. Okay. All right, so again, realize that some of this stuff you get a little bit better when you get the PDF, so you don't have to worry too much about actually grasping that part there. Okay, so here's our first example, finding a directional derivative from the definition. So if we have the arc cosine 3/5, find the directional, that should be everybody now. Okay. Find the directional derivative of f of xy in the direction of u, and so on. So, okay, so first of all, we need to know that are acute. So then that means that we would have sine theta Although, I mean, I guess you could have also known that as a 3, 4, 5 triangle, but okay. So now we want to calculate f of x plus h cosine theta y plus h sine theta. Okay. Given this part, so we will have x plus h cosine theta squared and then if you expand Okay. And then we can probably combine a little bit. So we would end up with x squared. Oh, we're plugging in. Sorry. All right, now we can combine. Okay. We are going to definitely need more room. Let me just add it. Okay. So we're going to now substitute all of that into the equation. We're going to use equation 4.36. Okay. I'll show you the image. I'll go back and show you the image when we're done. Okay, so we're going to combine a little bit. And we end up with 2xh. Oh, let's see. X squareds cancel, xy's cancel, and cancel. So then that is 2x plus 21y over 5. All right. So the only thing you have left to do is to plug in All right, so I'm gonna just show you guys this image real quick. Okay. All right. Okay, so we have a theorem, directional derivative of a function of two variables. The proof is in your textbook. If you would like to go over it, you may. I'm not requiring it on anything, but if you are curious, it is in there. And I'm sure we are about to use it. So, all right. Yeah, so go ahead and start. Just okay. So hopefully we're not going to need. Yeah, does not look like we're going to need a whole bunch of screens. So or slides. All right. So first we have to calculate the partial derivative. So let's find x. That would be 2xy minus y, or 2x minus y. So now okay. So you guys can see that you will end up with the same solution. before. Again, I don't care on your test which way you want to show it, unless, of course, it states that you have to use one method or another. For the next example, we are going to focus on equation 4.39. Right, so first we want partials. All right. Okay, so we have another theorem. All right, so we're finding a maximum directional derivative. Find the direction for which the directional derivative of the following at the point is a maximum. What is that maximum value? So the first thing we're going to do is find our partials. Oh no, you guys didn't see that yet. It's okay. Okay, so from there, then we find if you guys need the steps in between, feel free to write them. I'm just trying to fit more stuff on the slides. All right, so now we want to find this at the point -2, 3. So we're essentially going to do this. So that's going to be so next we need to find a unit vector that points in the same direction. So we want to divide what we just found by its magnitude. So that step will look like all right, so to find the corresponding angles to this unit vector, we need to solve the following equations. For theta. So that will mean since the cosine is negative and the sine is positive, the angle has to be in quadrant 2. So then theta the maximum value of the directional derivative at that point is the magnitude, which is 4 square root of 61. So maximum value. Let's see where we can shove that at. Okay, so now I will show you the visual. Maybe. Oh, I hit them wrong. There we go. All right. Okay. All righty. Okay. All right. So you guys can take a look at this closer on the PDF. Just trying to get us through a little bit quicker. Yeah. Okay, so first we're going to find we're just going to find the derivatives first. That's what you guys should do each time. All right, so now we need to evaluate it for -2, 1. So this vector is orthogonal to the curve at -2, 1. We can obtain a tangent vector by reversing the components and multiplying either 1 by -1. So, for example, we would have a tangent vector and I will show you this lovely graphic.
How again did you come to the tangent vector?
So since the vector is orthogonal at that curve, or at the to the curve at the point, then we took reversing the components and multiplying either one by -1. So they flip. So up here,
Oh, okay, yeah,
they
I
flip.
missed that part.
So flip. And then it doesn't matter which one. You can either, so they chose to multiply the 18 by -1. You could have also multiplied the 9 by -1. So
Okay,
another tangent vector would have been 18i plus 9j.
thank
Okay,
you.
cool. Good question. All right. We'll just say vectors then. Okay. For the next example, we're going to use equation 440 for both A and B. All right. Try and make it a little bit bigger for you guys to see it. All right, so part A. All right, so I think you guys at this point can handle finding your partials. So I'm just gonna go straight to if you do need me to explain anything, just let me know, but I just don't want to right, so that is your solution for part A. Actually, that's all they needed. I'm fine with however you need to work the work. If you need to write it out in the steps, go ahead and write it out in the steps. I won't hold anything against anyone. Having more work might actually help you on the test. That way, if you accidentally go too fast or you forget something, then you have it. Okay. Now, for this one, I am actually going to show you the pieces because I think it'll just be better that way. And then now we just have to shove it all into the problem. We have some definitions, a definition and a theorem. We might get through this all today. That would give me so much more time to work on your review and test. I know that doesn't sound fun to you guys, but it takes me a very long time, so makes me happy. All right, so the first thing we're going to find is the magnitude of V. And that's just going to be 3. Okay, so then if we do V over its magnitude, you can do the in-between step if you need to, but it would end up being negative 1/3 I plus 2/3 J plus 2/3. Okay. So that is the unit vector in the direction of V. So then that would mean that we would have, so out of that gives us cosine alpha equal to negative 1/3. Cosine beta equal to 2/3. And cosine at lambda. Blech. Greek letters, why do we still have to draw them? Also 2/3. So next we want to figure out our partials. Um, I don't think I can squeeze it, so I'll put it down here. Uh, so now we're gonna bring everything together. I think I'm going to do the first step in the answer. I'm not gonna do the in between. I think you guys will be able to follow along. So then that's going to give us negative 8 over 3x minus 2y over 3 minus 7z over 3. Okay, and then lastly, we just have to shove the point in. And it was 1, negative 2, 3. So that would be oops, minus. So then your overall answer would be negative 25 over 3. Okay. All right.